today's day. Okay, so 6, 7, and 12 we had to do. Okay, so all ticks today. Are there any questions on that first one, guys? So it was just basically like the ones that we practiced yesterday. You find your reference angle by taking the positive value. That's very important, right? So please remember, even though it's negative for your reference angle, you use the positive value, but you're going to work in the quadrants where cos is negative. So that was 2 and 3 for this one. So for quadrant 2, you do 180 minus, and then plus 360. So this was the first question in this exercise. I wrote in everything. But I mean, it's not the end of the world. Just remember, in a test or exam, the first time you use it, you have to. Then we just work that out. Next up, quadrant 3 is 180 plus. And then this is how the 0 to 360 thing, right? So this last line, because they said that your answer must be between 0 and 360. Remember that was in the question as well. So just check that you put those two values there. Now guys, how I got my first value was in my quadrant 2 solution, I made n equal to 0. Okay, so you can maybe just add that there underneath. You don't have to write that down as part of your answer, but that is where that came from. All right, in my quadrant 2 solution, if you make n equal to 0, you're going to have 144 plus 0, which is 144. All right, if you go to the next one, if you make n equal to 1, you're going to have 144 plus 360, which is going to be bigger than 300. So that is outside of the domain, I suppose, that they've given you, the restricted values. So it's bigger than 360, so that one doesn't work. So we're also not going to try 2, because 2 will also be bigger. If we try a negative 1, we're going to have 144 minus 360, which is a negative number, and we can't have negative number. Okay, so only that one works from the quadrant 2 solution. Nothing is add that in from the quadrant 2 one. And from the quadrant 3 solution, again, if I make n equal to 0 here, then that was how I got my second answer. Okay. And again, if you make n equal to 1, it's too big. If you make n equal to negative 1, it's too big. So those were the only two answers. In this case, guys, please remember you have to always first do the general solution and then get your specific. Okay. From what I saw now, we did that. Yeah, all the time. Right, number 2 has a little bit more work involved here in the beginning. Remember, you always have to isolate your third, your sine x. So first you take the plus 1 over and then become minus 1. And then you divide by 3. We have that sign with negative in quadrant 3 and 6. The reference angle, again, you take shift sign of the positive value always, which is 41. But because it was negative, we're working in quadrant 3, which is 180 plus the reference angle, and quadrant 4, which is 360 minus 30. Again, I just used in my quadrant 3 solution here, I did n equals 0 to get that answer. And my second answer was from my quadrant 4 solution, also n equals. That is how I got those two answers. and alright, let's look at number 12. Remember, I just asked you to change that color that would be called inside the four. The same thing as with the previous one, you take the plus root 3 over, it becomes minus root 3, and then we divide by 2. So again, this is negative and it's sign, so we're going to work in the quadrants where sign is negative, which is quadrants 3 and 4. If your reference angle by doing shift sign of the positive value, the 60. For quadrant 3 is going to be 180 plus 60. For quadrant 4 is going to be 2 minus 60. And again, the only two answers that we could get here was from the quadrant 3 solution if n is 0. And the quadrant 4 solution also if n is equal to 0. That's not always going to be the same, guys. I'll see if I can give you some where you will have more. But if they say, for example, you can go from 0 to 720, right? Your answers for x. Then you would have to have more. Then you would have to make n1 and get your answers. Any questions on these? Okay, we are going to continue working on these, but we're just going to make them a little bit more complicated today. Oh, yes, we can as well. Let's talk about tan first, actually. Okay, so you can do a heading trig equations with tan, I suppose. That sounds a bit odd, but I think the first is maybe not. We'll say with tan x. So trig equations with tan x. Guys, yesterday we looked at a sine graph, right? And we said that the period of the sine graph is 360. That's why we put a plus 360 in. Now, the period of y equals tan x, if we're just thinking of the basic tan graph, we're not going to draw it, but we can just think about it. The period of y equals tan x, can you remember what that was? 180 degrees. Sorry, not in. There we go, 180 degrees. So guys, when we are doing the trig equation with tan, instead of writing plus 360 in, we're going to write plus 180 in. Okay, so I'm going to write that. Therefore, in general solution, we're going to have whatever our reference angle was, whatever that angle is, it depends on the quadrant, and then we're going to say plus 180 in element of solution. So that's one thing that's different. Something that you have to remember. Whenever it's a tan equation, 180 is instead of 360. Okay, there is a second thing, but we actually have to do an example for you to be able to see what is different. So I'm just going to do one example. We're going to say solve for x. And the example, the question is going to be tan x equal to 0.75. Let's do that one. Now, just like we had yesterday, same method, that is a positive number, right? Tan is equal to a positive number. So you do the little Cartesian plane on the side. And in which quadrant will tan be positive? 1 and 3. Remember, CA is quadrant 1 and 3. Just like in the previous example, we're going to find our reference angle. So we're going to type in shift tan of 0,75. 36,87 degrees. All right, that is rounded off from the answer and calculator or within calculation. And guys, for sine and cos, we would say quadrant 1 solution and quadrant 3. Right? And you would get those general solutions. So let's write the quadrant 1 solution. We're going to say x is equal to, what do we use in the first quadrant again? The reference angle, so 36,87 degrees. But now because it's tan, I need to say plus 180 n. And since it's the first example for the day, let's add an element of z. Now guys, if I do 180, what do I do again for the quadrant 3 solution? I would say 180 plus, right? So if I have in my calculator, I'm not going to write it down now, but if I do 180 plus the answer, I'm going to get 216,87. So guys, what happens with this general solution here is I can actually get this answer if I use this general solution. So what is this general solution saying? 36 plus 180 times any whole number, right? So I can make n equal to 0. If I make n equal to 1, this is going to be 36,87 plus 180, which is exactly what I did here. So what happens with tan is we actually only have to write one general solution, because this general solution will give you the second general solution. So what I'm going to do is I'm going to write the second one. Okay, let's write the second one down. Then I'm going to make a note next to it that it's actually unnecessary. You are allowed to write the second one down, but it's just going to take extra time. Okay. But just to show you exactly why we don't need to, let's write it down. 180 plus the reference angle, which is 36,87, plus 180 n. And this is, what did we say now? 216, thank you. 216,87 plus 180 n. I'm just going to underline this, and I'm going to make a note. The quadrant 1 general solution will give us this value if n is equal to 1. So if I take my first quadrant solution and I make n equal to 1, I'm going to say 36,87 plus 180, which is exactly what I did in my quadrant 3 solution. So this answer will actually be, we will be able to get this answer from the first quadrant solution already. So therefore, we don't need the quadrant 3 solution. If we have an angle in the first quadrant, right? It can be any angle, and we add 180 degrees to it. Where do we end up? In the third quadrant. So whichever our angle is, or whatever our angle is, sorry, in the first quadrant, as soon as I add 180 to it, that will give me the third quadrant angle anyway. So what I usually do is I just do a little squiggly line through that bottom half. We are neither actually going to have to do a quadrant 3 solution for a tan equation, or if it was negative, we can just do the quadrant 2 solution, and we're not going to have to do the quadrant 4. Okay, so for tan, you only have to do one solution. So you don't understand why, but remember that. Okay, so for tan, it's right here. Therefore, tan equations will only have one general solution. Like I said, guys, if you forget this, right, and you do the quadrant 3 solution, it's not wrong. You will not lose a mark for adding that, but you also won't get a mark for adding. That makes sense. So they'll just give a mark for the quadrant 1 solution. That's where they'll stop marking. Okay, so you can write this if you forget that you only have to do one. That is just going to take a picture. Okay, so we can only ever one general solution. On any questions on that? You want to practice something later. All right, let's move on. We are going to do just a lot of in the book. Solve equations with one ratio to yeah, I'm gonna write Trig equations with complex angles. So basically what this means, guys, is now we're going to do trig equations where it's not just sine x or cos x or tan x, it's maybe sine of 2x or cos of, in brackets, x plus 20 degrees. Okay, so the angle is more complicated than what we did before. The method is still going to stay the same. So let's say solve for x. And for example 1, let's do sine of 2x is equal to negative, let's keep it positive, is equal to 0.3. Now guys, this is different from this. I just want to make sure that we all understand the difference between these two equations. Sine 2x is not the same as 2 sin x. Right? Do we remember with trig graph? I know we did it a long time ago, but if you have sine 2x, what does this 2 change of the graph? It's the k value here. Does anyone remember? It changes the period of the graph. Right? So if we were to draw this graph would actually have a period of 360 degrees, which is the normal period, divided by that k value, divided by 2. Okay, so when the 2 is attached to, when the coefficient of the x, this is actually part of the angle, right? In the other equation, what does this 2 do when the 2 is in front of the equation, in front of the sin x, in terms of the graph? It's the amplitude, hey? So the amplitude of this graph is 2. That means that it will go up to positive 2 and down to negative 2. And these are two entirely different equations. The most common mistake is that people want to take this 2 and divide the 0.3 on the other side by 2. You can't do that, right? This was the equation. Yes, absolutely, you can divide by 2. In this equation, what we have is we have a trig ratio with an angle. Right? In the previous one, we had sin x. Trig ratio equal to a number. Now we just have sine 2x equal to a number. It's the same thing. Okay. So we're going to do the same thing. Is 0.3 positive or negative? Positive. So we're going to work in quadrants 1 and 2. We're going to find our reference angle exactly like we did before. The reference angle is going to be 5 sine of 0,3. Yeah, that is shift sign 0,3. That is 17,46 degrees. We can round it off. We're going to write a quadrant 1 solution and a quadrant 2 solution. But guys, and I'm now going to be able to write x equals the angle that we did before. What is my angle now? Actually, my angle is 2x. But in the general solution, we're going to have to say 2x is equal to the reference angle. So quadrant 1, 2x is equal to, remember in quadrant 1, we just take the reference angle, 17,46 degrees plus 360 in. And write in element between times each day. And now what are you going to do with that 2? Divide everything on the other side by 2. Okay, so we have an extra step in that thing. Your first steps are exactly the same, but now because your angle was more complex, more complicated, you need to get rid of that 2 now. So you're going to say x is equal to, just on your calculator, you can divide by 2, 8,73. Plus, what's 360 divided by 2? 180. And guys, does that make sense? What was the period of this graph? 180, right? There we see, there it's coming in. We actually do end up with the period of this graph in our general solution. But we get it by dividing by 2 afterwards. Okay, we're going to do the same thing for our quadrant 2 solution. Quadrant 2, again, the angle was 2x. So we have to say 2x is equal to, what do we do in quadrant 2? 180 minus the reference angle. So 180 minus 17,46 plus 360n. So guys, at first you always do the normal period that you have. Always 360n, and then if you multiply by 2, you do that afterwards. And we quickly work this out. 180 minus. So that is going to give us an answer of 162,54 degrees plus 368. And now what if I do that 2? Again, I need to divide by. So this answer, which I still have on my calculator, divided by 2, is going to give me x equals 81,27 degrees plus 180. The important thing here is that whatever the angle is that you start off with, that angle is what your general solutions need to start with. Once you've written your general solution, then you get x on its own from that angle. Okay, let's do another one. On the equations on this side, they didn't give us an interval for x, hey? They just said solve for x. So that means that we're just doing our general solution. Okay. Number 2. 3 cos, and then in brackets, x minus 25 degrees, close brackets, plus 2 is equal to 0. And let's do x is an element of, let's do 0, 1. Let's do negative 360 for this one. What is the angle in this case, right? What angle comes after cos? X minus 25. So when we do it, our general solution, we're going to write x minus 25 equals everything else. Okay? In the previous question it was 2x, now it's x minus 25. Before we can do that, guys, remember from yesterday, we need to isolate the trig ratio with that angle. Okay, it doesn't matter if the angle is complicated. The angle has two terms in it, but that's fine. We need to get the cos and the angle on its own. So that plus 2 must go to the other side, and it's going to become negative 2. So I'm going to have a 3 cos x minus 25 degrees equal to negative 2. Now 3 I must still move, right? Because I'm trying to get cos and the angle alone. So the 3 I must move, and what's gonna happen to that? Divide. So I'm gonna have cos x minus 25 degrees equal to negative 2 over 3. And is that a positive or negative value? Negative. So I'm going to work in the quadrants with cos is negative. All right, so you can draw your little Cartesian plane. What's happening? Here we go. Where is cos negative? 2 and 3. To find your reference angle, just like we did before. It doesn't matter that the angle is complicated. The reference angle is still the same thing. Positive and negative one. So shift cos of the positive value. You remember that, right? That's still a thing. So we're going to do positive 2 over 3 when we actually calculate our reference angle. So shift cos of 2 over 3, and that is equal to 48. 19 degrees. Yeah, I did round that off, but you just put it in the calculator. So now we're going to have a quadrant 2 solution and a quadrant 3 solution. Okay, so quadrant 2, what was my angle that I started off with, guys? X minus 25. So that is what the general solutions, both of them, are going to start off with. X minus 25. What do we do in the second quadrant? 180 minus the reference angle plus what is the period of the console? 360. So we say 360. Now you can do this in 2 steps. You can do it in 1 step. Just because it's the first example like this, I am going to do it in 2 steps. So you're going to say 180 minus this. I have it on my calculator. 180 minus that answer is 131.81 degrees plus 360. How do I get rid of a minus 25? I have to add 25, right? That's the opposite of subtracting 25 is adding 25. So this minus 25, I'm going to now actually add 25 to that value there. So x is going to be this answer plus 25, which is 156.81 degrees plus 360. Guys, are you going to add 25 to the 360 as well? No, hey, they're not like terms, right? This is just a number. That is actually a variable because it has an n attached. Okay, so we're just going to add the 25 to the numerical part. The period of this graph is still 360. Okay, the period didn't change. What happens here actually, guys? What is an x minus 25? What does that do to your graph? Remember, if it's minus, it moves to the right by 25 degrees. Okay, that's what actually happens here. So this is like a normal point on the curve graph, but now because it's moved 25 degrees to the right, we added 25 degrees to that side. Okay, but the period stays the same. So pretty easy. All right, that was just our quadrant 2 solution. We still have to do a quadrant 3 one. Again, x minus 25 degrees equals, for quadrant 3, it's 180 plus the reference angle. Again, plus 360 n, guys, you really have to write it every single time. No, it's unnecessary, but you lose mark if you leave it out, or a mark if you leave it out even once. Okay, I'm going to do my 180 plus 48.19. Didn't really have to type that into the calculator, but it's fine. 228.19 plus 360 n, and again, the opposite of subtracting 25 is adding 25. So to get x on its own here, I need to add 25, so that is 253.19 plus 360 degrees. Right, not done yet. They told us that x has to be between negative 360. So now we must go do our specific solutions. I just quickly want to highlight these angles here so that we remember that, please. And now for the specific solution, guys, we need to list all of the angles, all of the specific values that we can get from these two general solutions that lie between negative 360 and 360. Okay, so we're going to say, therefore, x is equal to, I always start by making n equal to 0 in the two equation, right? Then I'll make n equal to 1 in the two equation. If it's too big, I'm not going to move on to 2. Alright, then I make n equal to negative 1. So let's start with n equals 0. I'll make a little note here on the side. If n is equal to 0, what are we going to get, guys? 156.81 plus 360 times 0. That's just 0, right? I'm going to get 156.81. So that fall into the interval that they gave us. It is between negative 360 and 360. So you're going to list it as one of your specific solutions. 156.81 degrees. To do the same thing in the second solution here, in our quadrant 3 solution, we make n equal to 0. Then 360 times 0 again is just 0, right? So we're going to get 253.19 plus 0, which is 253.19. Does that fall into our interval? Yes. So I must list that as one of my specific solutions. This in red, you don't have to write. Okay, I'm just trying to show you where these answers are coming from. Okay, if you look back. So please write it down now, but in a paper exam, you don't have to write the ready stuff. You can write the answer. Now, if I make n equal to 1, let's see what we're going to get. You can just use the calculator. You can do it in your head also if you want. It's just for speed purposes. 136.18 plus 360 times 1, hey? 516.81. Okay, so that is the answer that we're getting. Is that in my interval, guys? Is that between negative 360 and 360? No. So this one is not going to work. So I'm not going to list that in my actual list of answers. Okay. I'm going to actually just keep it here. What if I make, so now because n equals 1 gave me an answer that was too big, obviously n equals 2 is also going to, right? Because I'm adding even more. Now I'm going to make n equal to negative 1. Alright, let's see what happens. Negative 203.19. Does that work? Yes, it does. Hey, so if n is negative 1, I'm getting negative 203.19 degrees. And that one works, right? That is between negative 360 and 360. So that one I am actually going to list. If I make it negative 2, I'm not going to write this down, but if I make my n value negative 2, then it's too small, okay? Because it can go to negative 360, not past that. Okay, so n equals negative 2. For this one, we can do a similar thing. If n is 1, and then we're going to see what happens if n is negative 1, which values we get there. Now I'm taking this general solution, 253.19 plus 360 times 1, which is just the same as adding 360, right? Getting 613.19. 613.19. That is way too big, right? It's meant to just go to 260. If I change that 1 to negative 1, I'm going to get negative 106.18. Does that one work? Yes, okay, that is between negative 360 and 360. So we write negative 106.18. If I typed in negative 2, it would have been too small again. Alright, so those are the four specific solutions that I can get between negative 360. Guys, it all depends on this, right? Your number of answers will always depend on what interval they've given. If they just say from 0 to 350, then these two wouldn't have worked because these two are smaller than 0. Okay, so it really does depend. You always have to look at what is the interval that they gave you, and that's going to tell you which one. Like I said again, the stuff in red you don't have to write. You can just do it on the calculator like I did now. If you see that the value works, you write it down. If it doesn't work, you don't write it. Okay, so just to save time, I'm going to write it and just do it on the calculator. Alright, let's see. I think I want to give you guys time to work on some of these as well. What are we doing tomorrow? Okay. Is there any questions on any of the ones that we've done today? Okay. All right, I'm just going to give you one tan question that doesn't have a complicated angle because we haven't practiced those yet. So if we are looking at exercise 15 on page 155, number 2, and the question is tan x is equal to negative 2 from 4, 1. But they are saying that x is between 0 and 360. Alright, so you're going to have to write specific solutions for that one, for number 2 there. But then from exercise 17, number 1, 3, these are all just general solution questions, so you don't have to do this last step. Okay. So that's the first one. Alright guys, in all of these, remember you need to have your trig ratio and an angle equal to a number. So in the first one, that was already done for you. You can just go straight into choosing your quadrant, getting your reference angle. In this one, it's also fine. It's already assigned as an angle equal to a number. And in number 3, the same thing. But in number 7, you're going to have to isolate the trig ratio and the angle first. So you're going to minus 1 and then divide by 3, right, in number 7. And the same thing in number 8. You're going to divide this number by 2 before you do your whole retrospective. Okay. So start working on that now. You have about 30 minutes. No, around 18 minutes, sorry. So you can do a good number of these in that time.